This is Group 19's vodcast on the application of the derivative in economics. There are two concepts of derivatives in mathematics, one being the geometrical, where the derivative is the slope of a curve, and the other being physical, where the derivative is a rate of change. Derivatives first came about thousands of years ago when goods and services were bartered for. For instance, I could take a perishable item to Daniel for some of his wine. In turn, I could then trade my wine to Luke later on for another perishable item, thus wine acting as a currency to set the value of two perishable items from two different times. There are rules that we can follow to find many derivatives. A few common ones are the power rule, the product rule, the quotient rule, and the chain rule. The chain rule is very interesting as it allows you to find the derivative where the function has a function within it. Derivatives are used just about everywhere, in mathematics, physics, chemistry, economics, engineering, and everyday life. The application of mathematics has become increasingly existent in the world of economics over time. Every day, businesses handle countless operations that continually rely on mathematical functions. Included in these functions is calculus, more specifically, the use of derivatives. These are applied to assist in making operational decisions and consequently help manage a company's daily flow. Perhaps three of the leading examples of these functions are marginal cost, marginal revenue, and maximized profit. Within economics, the rate of change in relation to specific quantities can often provide valuable information regarding business decisions. Commonly referred to as C of X, businesses are often concerned with the total cost of production, given by C, in relation to a specific quantity, given by X. Applying calculus to this, we can therefore see that the derivative of C of X is the rate of change of the total cost in relation to the number of units produced. For example, company LDF's total cost for producing X items per year is given by 6 plus square root of 4x plus 4. Applying calculus, we then know that the marginal cost is equal to 2 over square root of 4x plus 4. Continuing with this example for our company, if we wanted to know the marginal cost of production at a quantity of 10, the derivative of C of 10 is then equal to 2 over square root of 4 times 10 plus 4. This is equal to 0.30151, meaning that for each additional increase in production, cost will increase by this amount. Once a company has established a revenue function and a cost function, they can then calculate their profit function in order to maximize profit. This is simply calculated by finding the difference of the revenue function and the cost function. Therefore, company LDF's established revenue function, given by R of X, is 2x cubed plus 40x squared plus 8x. And the established cost function, given by C of X, is written as 3x cubed plus 19x squared plus 80x minus 800. To find the price per unit to maximize profit, the firm calculates the difference between these two functions. Thus, applying what we already know, the company's profit function is negative x squared plus 21x squared minus 72x plus 800. The company can then use the first derivative to calculate the critical numbers of the function. This is given by negative 3x squared plus 42x minus 72. Factorizing this, we get negative 3 of x minus 2 times x minus 12, with the critical numbers being x equal to 2 and x equal to 12. Testing with the second derivative gives the company negative 6x plus 42. The relative maximum of the company is therefore 12. This is the quantity in which to produce at in order to maximize profit. Consequently, to determine the price in which the quantity of 12 should be set, the company calculates R over X equal to 2x cubed plus 40x squared plus 8x over 2x squared plus 40x plus 8. Therefore, producing at a quantity of 12, P of 12 is equal to 2 times 12 squared plus 40 times 12 plus 8. In conclusion, to maximize profit, the firm should produce a quantity of 12 units priced at $776.